Good evening, one and all. This is Dr. Aravind Pandian. So let me introduce the speaker now. It's my great honor to introduce our eminent speaker, Dr. B. Ashok, a globally known leader in the field of automotive engineering and electric vehicle technologies. He is an eminent scholar and expert in automotive engineering, currently serving as the professor and HOD of the automotive engineering, VIT Vellore. He did his PhD in automotive control system from VIT Vellore and PDF in hybrid powertrain calibration from Ahmadu Bello University, Nigeria. Dr. Ashok's expertise spans electric and hybrid vehicle systems, powertrain calibration, and advanced manufacturing techniques. With over 14 years of research experience and a cumulative impact factor of 635.9 from 190 international journals, recognized him as among the world's top 2 president scientists by Stanford University for 4 consecutive years. He has led 12 funded projects worth over rupees 5.3 crores, focusing on sustainable mobility, energy management, and AI-driven automotive innovations. His professional journey includes groundbreaking research, teaching, and administrative roles. He has visited 20 universities globally, collaborating on cutting-edge automotive solutions, and has filed multiple patents, including 1 grant for an innovative radiator design. His contributions to academia include developing programs on EVs and smart mobility, along with creating state-of-the-art research facilities. An award-winning researcher and educator, Dr. Ashok continues to inspire and lead advancement in the automotive sector. We are truly fortunate to have you with us today, sir. Let us go for this session, sir.
Good evening, participants. I would like to thank the management and the committee members of the Crescent University to invite me to participate in this FDP. So at the outset, today we are going to discuss about the powertrain system architecture of the electric vehicles. So basically, if we understand that the architecture in the sense the arrangement of the various components to form as a final system. So especially if you take in case of IC engine based vehicle or hydrogen engine based vehicle or whatever the vehicle powertrain. So according to the energy utility or according to the energy used, this powertrain architecture will be varied. So basically, the powertrain, as the name implies, it is a combination of the power producing and as well as the transmitting device. From the power producing device towards the final end wheel, we will call it as a powertrain system. So this powertrain system will be varied for the different types of electric vehicles. There will be some drastic variation between one type of electric vehicle to the another type of electric vehicle. For example, if we classify the electric vehicles, we can broadly classify this EV into 4 different types. So in this 4 different types or whatever the electric vehicle system, the architecture is defined to be unique as compared towards the IC engine, you can say the electric vehicles. Recently, the Mahindra has developed the in-glow platform for the electric vehicles. That is, we'll call it as a born by electric. So this particular platform is mainly proposed or developed from scratch for electric vehicle itself. But whereas if you will see the other electric vehicles, say Tata, Nexon, or whatever the other electric vehicles which is prominently running in the market. So that are all IC engine platform, and it has been converted to electric vehicle platform for the electric vehicle powertrain applications. So there will be a drastic difference between the born by electric and converting the IC engine platform into the electric vehicle platform. But even though whatever the platform, so the as a outset we can say there is a major difference in only the powertrain. In the conventional IC engine vehicle, we will call it as a ICE vehicle. Their IC engine and the respective gearbox only will be used. But whereas if you take in case of the BEV vehicle, it will uses the electric motor and related components along with the battery, and the transmission system alone will be worked. So as a overall layman perspective, there is a overall like this way only the difference will be noted. But if you will see in case of the in-depth understanding or in-depth aspect, there is a huge difference with respect to the electrical wiring systems. That electrical architecture itself, there will be a huge difference between the IC engine platform towards the electric vehicle platform. 10-15 years back at all, the vehicle development time will be very much high, and it is very much competitive, and cost involved also more. For launching one new vehicle, it will take more time. But recent days, this platform concept has been introduced. From the platform, the vehicle will be built. So in the platform, what is the platform means? Basically, in the platform, as much as number of components will be shared from powertrain towards the electronics, electrical, chassis system, steering, and every components will be shared among the vehicles. So that's what, for example, this in-globe platform from Mahindra means. So in that, the maximum components will be shared between E6 towards another vehicles, or multiple variants can be developed from that platform. So in that platform, the powertrain is one of the important aspect. So the name implies where the electric vehicle is not new to the automotive industry. So the very first electric cars will be produced in late 19th and early 20th century. But during the time, the major setback in the electric vehicle is the battery size and the battery charging, or you can say the energy storage is one of the major drawback. So at the time, compared towards the electric vehicle, this IC engine vehicle offers more advantage in the terms of refueling, cost, and all those things. But over the period of time, we understand that this IC engine becomes a negative aspect towards the environment, and as well as the fossil fuels is also finite. It will starts to reduce. So thereby we need to move towards, or we need to find for us some kind of alternative measures in terms of powertrain changing from the conventional IC engine vehicle towards the electric vehicle. So here, if you take in case of the what are the key components in the electric vehicle powertrain system means, basically this 5 components are finds to be the key component in the electric vehicle systems. That is the electric motor and power inverters, electronic control unit, energy storage system, which it may be a battery in case of battery electric vehicle, whereas in case of the fuel cell vehicle, it is a fuel cell, and followed by the corresponding transmission and the final drives. So put together, we will call these 5 elements, we will call it as the electric powertrain system. So this electric powertrain system from one vehicle to another vehicle will constitute this 5 components as a major one. And of course, some other minor components are also there. For example, energy storage means if it is a battery, the battery is also having the energy management system. That is also another controller. Battery thermal management is part of the battery management system. So likewise, there are many components are there, but majorly we can club as a electric vehicle in terms of this 5 different components. So here the diagrammatic representations of the what I call various EV powertrain components. So here you can notice that there are 2 batteries that have been mentioned. One is 12-volt battery system, and another one is a traction battery pack. So the traction battery pack is typically the higher rating, higher current and voltage rating. But whereas the standby battery, that is the conventional 12-volt battery, will be the smaller in size. So the purpose of the 12-volt battery system is to provide the what do you call the supply, or you can say the power of the electrical accessories, starting from horn system, lightning system, whatever the 12 to 14 volt systems are there in the vehicle, that particular components will be powered up with the help of the what do you call it, 12 volt battery system. And whereas the traction battery system will plays a key role in powering up the traction motor, which is used to propel the vehicle. So, so in this case, where this 12 volt battery system will be getting power, means it is getting the power from the conventional, traction battery pack through the DC to DC converter. So the high voltage, typically, if you see, the traction battery pack will be vary from 48 volt or 72 volts, or even it will, in some cases, 60 volts also. The two-wheelers from 60 volts to 600 or 800 volts also you can able to see in case of the heavy commercial vehicles. So that higher amount of voltage will be converted into 12 to 14 volt with the help of the DC to DC converter. And comes to the another important aspect is the charging system. So where the charging system will plays the major role in recharging the battery towards the effective using charge level. So that again, that that also it will come up with a different what do you call cost effective or the different charging time effective variations. And similarly, the traction motor. So the electric motor is not a new concept to the technological community. The electric motor has been used for prolonged time in various applications apart from the automotive segment, home appliances, similarly the toys, like different applications. This electric motor has been used, industrial appliances and all those things, industry applications, productions and all those things, automation. But however, there is a major difference between the electric motor used in these applications as compared towards the vehicle application. And even though in the vehicle also the motor has been already used in varieties of places like piping system, starting system in case of the IC engine vehicles. So likewise, the motor has been playing a major role. But however, the motor requirement for the vehicle operations or the vehicle application will be drastically differed as compared towards the mentioned applications like automation or industrial applications and as well as the home appliances likewise. So the same by means of same features are the operating characteristics. We can't able to develop a motor for the electric vehicle application. So this is the way the components in the e-powertrain, that is we'll call as a electrical powertrain or electric powertrain system. So here the electric machines, so there are different type of electric motors can be used, starting from the AC motor or a DC motor, or in the AC or DC itself there are many subcategories like BLDC, SRM motor, different categories of motor, anything type of motor can be used. And that electric motor switching features or the switching function will be done with the help of the inverter. So that is one of the important component in the electric vehicle powertrain system. And it comes to the battery pack. So that battery pack, it will be in the form of a group of cells. It will joined together, it will form as a module, and a group of modules will form as a battery pack. So from the battery pack through the DC to DC converter, the 12-volt battery will be recharged. And similarly, with the help of the onboard charging system, this 12-volt, this high voltage battery pack will be recharged from the external source. So next important component is the motor control unit. Usually we'll call it as a MCU or a ECU. ECU is a generic name. That generic name can be called for any applications. Like for the ECU is used to control the airbag, then we will call it as airbag ECU. And similarly, if it is used to control the braking system, we'll call it as a ABS ECU. So likewise, in e-powertrain, the ECU is used to control the motor operations. And similarly, the another important component are the various power electronic components are being used in case of the electric powertrain. These power electronic components are used to the switch the or control the power flow between the energy storage system towards the system where the energy will be transferred. And the next one is the transmission system, where the power produced by the motor drive shaft, it has to be transferred towards the rotating wheels. Then only the appropriate traction will be generated. And of course, the last and most important one is the battery pack. It is the battery pack is the combination of the cells. So how the electric vehicle configurations will be arranged means, so basically the driver is pressing the accelerator pedal means immediately the control will be gone towards the vehicle control unit, or otherwise it is called as a motor control unit. In some cases it has been represented as the vehicle control unit. In some cases it has been mentioned as the motor control unit. So from the motor control unit or the vehicle control unit, it will calculate what is the total torque demand in the vehicle. So of course, in the vehicle control system, everything will be realized in the form of a torque-based engine control or a torque-based vehicle control system only. So what is meant by the torque-based vehicle control means? So instead of rather than the torque requirement from the vehicle or from the powertrain, it may be engine or it may be a motor. So what are the factors which will be requiring the torque from the power producing system means driver may require steering system or any auxiliaries systems, AC system, cruise control systems, like that. Different systems will be requiring the torque from the engine or a motor power in the power producing device. So in order to satisfy the torque, the respective motor or engine, in some cases it is hybrid motor and engine, both has to work over it. So in order to avoid the confusion nowadays, this torque-based engine, torque-based powertrain control system has been formulated, where the cumulative requirement of torque from the various system will be calculated, and according to the torque requirement, the torque will be realized with the help of the what you call the designed control or control systems. So of course, that is the role of the vehicle controller. So depending upon the torque requirement, the vehicle controller will calculate or identify this is the torque required from the motor. So according to the torque requirement, the appropriate amount of current has to be regulated to the from the battery to the what you call the motor. So that role is being done by the power converter. That's what we'll call as a inverter. So that will be doing the switching characteristics between the what you call the vehicle controller towards the electric motor. So that is the important aspect in the what you call the electric propulsion system. So from the power converter, the electric motor will be getting the supply, and from motor it will be given towards the mechanical transmission system. So, and whereas if you comes to the energy source system, so there we know that the energy source, that is nothing but either it is a battery or it is a fuel cell. Most widely as of now, the lithium-ion based battery systems only will be used as widely, and in order to manage its function in an effective manner, controlling manner, that also will be managed and controlled with the help of the separate controller we'll call as a battery management system or energy management system, and of course that will be refilled with the help of the charging system. And other than that, the auxiliary subsystems may include power steering system, climate control unit. Likewise, many auxiliary system will be there. So that also sometimes it requires the power from the traction battery pack, or as I mentioned earlier, that particular power also can be taken from the what do you call the 12 volt battery as well. So in order to understand the powertrain architecture, design philosophy for electric vehicle, one should have the mixed up knowledge, that is the interdisciplinary knowledge from the automobile engineering sector towards the electric vehicle, electrical energy engineering, in order to attain the electric vehicle architecture design systems. So if one should have the enough knowledge in this two aspects, then only they can able to design an electric vehicle in an effective manner to provide a better fuel economy or a cost or a performance and a better application aspects. So another important aspect is the best power system configuration or a power system architecture is still evolving only for electric vehicle. Why it is still evolving means, see, hardly for past 5 to 6 years, only this electric vehicle is becoming dominant, and whatever the research which has been happening in the electric vehicle are most widely in the scenario of last 5 years or 10 years. But if you'll see the legacy of IC engine, it has almost 60 to 70 years. The IC engine has been running in a very better manner. So in that case, for 50 to 60 years, the R&D has been very well established and developed while using the IC engine. But whereas if you will compare towards the electric vehicle, it has been evolving very recently, and still there is a much more scope and gap for the electric vehicle research. Still, that is the reason where still the finalized or the optimized power system architecture has not been introduced. So what are the different configurations which is present in the electric vehicle means, depending upon the arrangement of the motors, we can able to differentiate the different configurations, starting from 3 motor configuration, 4 motor configuration, either 2 motor configuration or a single motor configuration also. So either of these configurations are being what you call the electric vehicle system. There is a advantage between one system configuration to another system configuration. For example, if you take the 4 motor configuration, so thereby we can able to omit the braking system, or it is easy to control and handle the vehicle. So if you have the control logic effectively to control the 4 different motors, and likewise to system, and there in case of 4 motors, there is no need of a differential gear, because each individual will be controlled with the help of the what do you call it will be controlled with the help of the motor. So there is hence there is no need for the differential gear system. And likewise, 3 motor configuration also has been used in certain vehicles. So the very first part of the electric powertrain is the electric motor in EV. So of course, as I told, this electric machine or the motor, the varieties of motors has been started to use in the what we called electric vehicle application. So we can't able to judge at present this motor will be good for this application or that motor will be good for another application. For example, if you take in case of IC engine based platform, usually we will say for a heavy commercial vehicles, the diesel engines are better because it is producing the better torque, like that aspects. But whereas if you see the conventional systems or the electric vehicles, the scenario will be totally different. And if you will see the electric vehicle as a specific requirement as compared towards the conventional IC engine vehicle systems. So one vehicle may use one type of motor, another vehicle may use another type of motor. But as I told, the usage of motor will mainly not only depend upon the power or performance. Most importantly, the cost and as well as the what you called availability of the components or availability of the sourcing of the components. So depending upon the factors like high efficiency, instant power, torque response, power density with low cost and high acceleration are the major requirement of the electric vehicle motors. So as I told, this electric vehicle motors specific requirements are being varied from one application to another applications. So, but the most prominently used type of motors in the electric vehicles are the brushless DC motor, PMSM motor, three-phase AC induction, and followed by the switched reluctance motor and the synchronous reluctance motors. And apart from this, some new type of motor also has been developing, like axial flux motor, different aspects been developed. And another important aspect is that we can't able to define this motor as suitable for this as of now. For example, heavy commercial vehicles means we can say the diesel engines are better for what you called two-wheeler applications compared to diesel engine. Petrol engine will be better. Similarly, passenger car applications also to the petrol engines will be better. So likewise, we can able to give an appropriate requirement. But still, in case of electric vehicle, we are not in the position to exactly define this is motor is suitable for this application, or that motor is suitable for the another application likewise. So compared to by comparing the different motors, each and every motor has its own pros and cons are the requirement. Say basically these are the parameters by which the motor or machines will be selected for the application, like power density, efficiency, controllability, reliability, technological maturity, and finally the cost. So according to this value, we need to select the motor. One motor may provide better in power density, another motor may provide better in efficiency. So we need to create some optimized solutions to while selecting the motor. And another important aspect is that the availability of materials. So that will also be in the major impact while selecting the motor. And compared towards the different motors, the different vehicles, starting from Peugeot, Citroen, Nissan, Honda Insight, different vehicles uses the different types of motors, but most widely or prominently used motors are the PMSM, permanent synchronous reluctance motor, and the induction motor, and similarly BLDC motor also finds certain application in the two-wheeler segment. So likewise, the operating characteristics, if you will see compared towards the traditional industrial motors, it needs to operate at a temperature range up to 40 degrees Celsius. But whereas if you take in case of the electric vehicle motors, sometimes it may be able to operate in the range of up to 140 degree Celsius also. And similarly, speed range is very, very wide in case of the electric vehicle applications. Up to 15,000 RPM, it has been requirement. But whereas in case of the industrial applications, it is up to 3,000. And more importantly, the constant speed is very much optimum in case of the industrial applications. But this is not applied in case of the electric vehicle motors. Frequent start and stop. So likewise, different requirements are there. So according to this requirement, each and every motor has its own pros and cons. Accordingly, it will be selected. So, and more importantly, while selecting the motor, this performance of the overall performance of the vehicle will be important. Overall vehicle performance in the sense how much power needs to be produced, at what is the power band region, what is the torque band region. So, what is the driving range efficiency? What is the driving range and efficiency? So, likewise, the cost and these things needs to be considered while selecting the proper rating of the motor. So typically, depending upon the traction motor characteristics curve, this will be what I called considered or selected while going for the motor selection process. So, for example, one interesting fact is that not like IC engine, it has a very narrow power band region and torque region in case of the IC engine. But whereas in case of the traction motor, electric motor, it has a very constant power region for a very wide range and constant torque range for a very short range. Is one of the major what he called difference between the conventional IC engine towards the electric motor applications. So the range for the constant power operation depends primarily on the particular motor type and its control strategy. So according to this, another interesting fact is the electric motors will be able to produce the very high efficiency. The efficiency region or the zone, it can be seen up to 90. Even nowadays, the motors are recent motors are can able to produce up to 95 also. So the very lowest efficiency it is in the range of 60. But if you see in case of the IC engine, the very highest efficiency itself is a 60 itself achieving it's a very bigger requirement. So compared towards this traction motor characteristics, so this usually depends upon the speed ratio. The speed ratio is nothing but the what do you call the speed towards the maximum speed towards the rated speed. We will call as a what do you call the base speed in the electric motor. So depending upon the, for example, for different types of motors, the different base speed will be followed. Say for a switch reluctance motor, the base speed must be greater than 6, whereas for induction motor it will be up to 4, whereas for a VLDC motor it will be up to 2. So depending upon this base speed ratio, the type of motor selected it will be varied. So accordingly, we can able to vary the power output. So accordingly, the gearbox selections and those things will be varied. And comes to the second component in the powertrain system is the motor control unit. In some cases, it is also called as a vehicle control unit. In some vehicle, they will be calling it as a vehicle control unit also. As rather than the specifically motor control unit. So more importantly, this particular motor control unit has a number of inputs from the driver, from the vehicle, from the other systems, environment. Likewise, different inputs will be given towards the motor control unit. So based on that input, so finally it will able to provide the output for the effective operation. So the control unit works in combination of the various sensors, actuators, and safety device to perform the various functions allotted to the set of control algorithm. So basically, it is a microcontroller based control system which is used to control the motor. And it has a varieties, as I told, it has a varieties of sensors starting from the vehicle speed, driver requirement, for example, accelerator pedal position. If it is a gearbox is used, it is a gear position or a gear level. And similarly, the braking, battery conditions, likewise, and many aspects will be included. And accordingly, depending upon the requirement, the motor control unit will able to perform the various functions like starting and stop of the motor, changing in the rotation direction during the taking reverse function, all those things, control the speed and torque, overload protections, prevents any electrical fault. Likewise, various functions will be done by the motor control unit. And depending upon the motor control unit input to the inverter, the current from the battery will be regulated to the motor. So typically the output of the motor control unit will be in the range of 5 volt control signal. So that 5 volt control signal will be given towards the switches which is present in the inverter. So power switch also with inverter will be also called as a power switches. So depending upon the power switch, depending upon the power switch, the current from the battery will be regulated towards the. So this power electronics plays the major role in the motor control operations. So not only motor control operations, in electric powertrain, power electronics has a wide application, starting from inverter, converter, onboard charger. So likewise, the varieties of solid state devices based systems will be used for controlling the or operating the powertrain system. For example, the regenerative braking requires the AC to DC converter. Onboard charger, it will require the AC to make in another AC to DC converter. If it is a dual battery system is used, it needs a DC to DC converter. The traction motor requires DC to AC converter, that is the inverter. So likewise, each and every systems will require the different type of power electronic components to perform the function. So this is typically the powertrain itself consists of the inverter components over the system. So while designing these powertrain components, the main trends or the technological advancement needs to be considered. So like the cooling technology, fast switching frequency, similarly the size, material availability, likewise many aspects needs to be considered while selecting the power electronic components. So similarly the voltage range, more importantly. So the ranges of the voltage for the different category of the vehicle will be shown over here. For example, for a two-wheeler, the voltage range will be in the range of 48 to 72 volts. But whereas if you take in case of that also it is applicable for the three-wheeler vehicles, and similarly the passenger cars, it will be in the range of 400 volts, or even nowadays it is coming up with a very higher value also. And for the heavy commercial vehicles, it is going up to 800 volts also, it is possible. So as I told, this motor inverter, it is to convert the or switch or you can say regulate the power from the battery to the motor with the help of the what do you call it, control unit or make motor control unit. And this DC to DC converter, which is used to recharge the 12 volt battery system from the high voltage battery pack, or in certain cases this will be done. This is also used to power up the all electrical accessories, 12 volt electrical accessories which is present in the vehicle. And similarly for charging external from the external source, this AC charging systems, AC to DC converter will be used. And for the fast charging, direct DC to DC converter will be used, where the high voltage can be converted into respective to DC aspect, and the charging time can be reduced. And next, and another important component is the transmission system. So there is a question always arise. The transmission system is required for electric vehicle or not. So without transmission system, the electric vehicle can be operated or not. So as we know that for IC engine, the transmission system is very important, because due to the power fluctuation produced between the different strokes, or you can say the power fluctuation in the IC engine. So we need a power and torque fluctuation. So we need a transmission system. But whereas if you take in case of the electric vehicle, transmission is not a mandatory, but without transmission system also we can able to operate. But by means of using the transmission system, we can able to effectively provide the better performance in the vehicle. It may be a single fixed gear or a multi-transmission system, as like a what you call IC engine vehicle also. It can be used it. So ultimately, in order to achieve the better drivetrain efficiency and vehicle performance, the transmission can be used. So the transmission types may be used in case of electric vehicles are varied from single speed transmission towards multi-speed transmission system, automatic manual transmission, CVT, DCT, and automatic transmission also can be used. And the next and foremost important component is the battery in electric vehicles. So nowadays the cost, complexity, acceptance of the electric vehicle, similarly penetration of the electric vehicle, all the growth and positive or negative, all the aspects of the electric vehicle will be circulated or centered with the proper battery usage. So for the electric vehicles, there are varieties of batteries will be used, starting from lead acid battery towards nickel metal hydride, and finally the lithium batteries, and of course fuel cell is also under that development. So why these lithium batteries are most widely preferred for the electric vehicle application means it has major advantage in terms of cost effective, energy efficient, temperature variations, weight, life cycle, and more importantly, the energy density. So the specific energy density, which is nothing but the amount of energy stored in per unit area, is much higher for the lithium metal as compared towards the other type of batteries. So this lithium battery is available in varieties of shapes or varieties of component shapes, like button type, cylindrical cell type, pouch cell type, prismatic cell type. But this pouch, cylindrical and prismatic are most widely used. Whereas the cylindrical cell is most widely used in case of the what you call most widely used in case of the Tesla based vehicles. But whereas if you see in case of the BYD vehicles are recently launched, this Mahindra vehicles use a blade type batteries. That is a specific type of battery technology which is developed. So, and again in the lithium itself, there are 5 to 6 chemistries are available with respect to its usage of components. The oxide, metal oxide components used in one type of battery will be varied from another battery, like lithium cobalt oxide based, lithium titanate, or lithium manganese based, lithium LFP, that is most widely used and cost effective. Each and every chemistry has its own advantage and disadvantage, and depending upon this, the characteristic features or the property variations, this type of chemistries will be varied. So in order to construct a typical 60 kilowatt batteries, this a typical 60 kilowatt battery is used in the Tesla Model S vehicle. It requires 185 kg of various minerals. So among that, 28% it is from the graphite. So totally this 185 kg includes 28% from the graphite and around 19% of aluminum, 10% of copper, and more importantly, lithium requirement is around the what you call 3.2%. That is a 6 kg. And similarly, the availability of lithium is very, very finite. That is the another important reason in challenging towards going for the lithium ion battery. So ultimately, what is present inside the battery pack? So typically, the battery pack is arranged in such a way that the multi cells will be formulated with the help of the electrodes, and multiple cells will be connected together to form the module, and multiple modules will connected to form the pack. And finally, the pack will be stored in the respective place in the what you call the vehicle. So the location of the battery location has been very different in the rear side or in the floor side. Most widely, the floor location will be followed for the battery in the electric vehicle. And next, the important component in the battery system is the BMS, that is the battery management system. So what this is another controller. So like how for controlling the motor, there is a one microcontroller based system will be there. So likewise, this battery management system also requires another controller. So that particular controller is used to control the various functions, starting from the temperature control, the cell balancing control. The cell balancing in the sense, if typically 1,000 cells will be connected together, means so all the cells has to be equally discharge and charge. So that has to be properly done with the help of this what they call the BMS system. And likewise, state of charge estimation, state of health, state of temperature, thermal management, any fault diagnostics, power management, production, all these things will be done with the help of this BMS. So ultimately, it will protect the battery, it will diagnose any fault, performance management, all these aspects will be done with the help of the battery management system. So the internal architecture of BMS includes varieties of components. So the various inputs coming from the batteries are the current, voltage, temperature, motor related input, environment related input, and other certain inputs of other systems also will be taken into account. And accordingly, the exact voltage or exact temperature cannot be predicted, calculated, measured. So only it can be able to be predicted with the help of the battery model, which consists of the electrochemical model and a thermal model to measure the proper temperature. And similarly, electrochemical model is used to measure the from that we can able to estimate state of charge, state of health, or state of power, or state of temperature. So accordingly, it will able to, these values will be used to for the driver indication, for monitoring the state of the system, state of the vehicle, for planning for the further control actions likewise. And similarly, depending upon the temperature, the thermal management needs to be controlled. So either it will use as a liquid cooled or a air cooled or a refrigerant based cooled or a combination hybrid based cooling system. Any type of cooling system also can be used. So that cooling functions will be regulated with the help of the input from the temperature model. And likewise, cell balancing module that will use to balance the cell. If one cell is at a higher charge and another cell is at a lower charge, it will try to discharge the higher cell locally, or it will transfer from higher cell to lower cell and vice versa, depending upon the either it will use as a active balancing or a passive balancing mechanism. So all these functions will be done with the help of the what we call the BMS system. And another important function of the BMS is the battery thermal management. So it is also part of the BMS. So the battery thermal management has a function of cooling, heating, insulation, and ventilation. So during cold condition, it has to heat the battery and sustain the reaction rate. During the hot condition, in a vice versa manner. And similarly, insulation and ventilation. These all the aspects needs to be done with the help of the battery thermal management systems. So to summarize the overall discussion, today we have discussed about the various electric powertrain components, starting from the electric motor, where the different types of motors will be used, starting from AC towards the DC type, and followed by the power converters, where it uses IGBT based or a MOSFET based system, or any type of GTO based system or a BJT system for to control the regulate the power flow between the electric motor to the battery system with the help of the motor control unit. So within this context, I'm concluding my presentation. If you have any queries, please feel free to interact.
Yeah, sir, this is Godwin from Crescent Automobile. I have a query regarding the PMS development.
Yes, please.
Sir, actually, how this model-based development is involved in BMS development, and can you specify any basic controller options or development board options that you are working on?
See, basically, this model-based development, or we will call it as a MPD. This is one of the important development strategy which is followed in modern automotive community. So here it involves a various stages. There is a V model design will be followed, and in that the very first aspect is the model. Varieties of simulations will be used, like model in loop simulation, software in loop simulation, hardware in loop simulation, and finally the vehicle in loop simulation. So for this, the varieties of software, starting from the most prominent software used is the MATLAB or Simulink, and MATLAB Simulink. Other than that, as said, AME Sim, LabVIEW, like different softwares will be used. So here the flow of the model-based development is first we need to replicate the mathematical model of the physical system. Say if you are going to develop a battery management system for a 3 kilowatt battery mains. Here the system is the battery and the BMS is the controller. Both needs to be physically developing, means it is more cost and time consuming. So both needs to be modeled with the help of the any available software. So here the model in the sense as a mechanical term, it is not a 2D model or a 3D model. This model, whatever I'm saying, is the functional modeling, where it includes the operation of the system. So it is a battery, means it will, the function of the battery is to charge and discharge. So that functions the battery has to provide. That likewise the model has to be developed. Likewise the controller, means the controller has to take the inputs and process the inputs and provide the output. So this both needs to be merged and needs to be simulated in the model in loop. So here everything will be in a model. And once the controller development is fine in model in loop, then we will go for the software in loop, where the controller model will be converted into C codes. And that C codes will be working effectively or not. That will be checking in case of the software in loop, and followed by the hardware in loop, we can replace the hardware controller, and finally we'll going towards the vehicle in loop where the everything will be in a hardware format. So likewise, this stage will be going for one type of controller to another type of controller. So this is the process which is followed in the model in loop simulation. I hope.
Yeah, yes, sir. Sir, what kind of hardwares that we can employ for this hardware in the loop?
See, this hardware loop can be used for any kind of controller system, control system design. Say, if you want to design a controller for a motor control, there you can use the motor as a hardware, and a DSP based board, or a real-time target board like or a real-time target machines like XPC target or DSpace, like that hardware also can be used. So it depends upon the cost, complexity, and the requirement.
Okay, sir. So if the budget is a little low, then for a basic BMS development, can you suggest
It is better. So it is better to go with the DSP based board hardware, DSP based board. It is feasible.
Okay, okay, sir.
Sir, good evening, sir. This is Balasrinivasan from Crescent.
Sir, good evening, sir.
Sir, I have one doubt regarding fast charging. Like how well or like how bad the fast charging is going to affect the BMS?
Ultimately, the BMS will not be affected by fast charging. The fast charging is majorly affecting the battery life, or battery health, or battery safety. So that more importantly, the BMS will prevent the effective controlling of the fast charging. So if the BMS is well effectively designed in order to predict the charging variations, or in order to react towards the temperature variations, so we can able to prevent the battery failure or a battery life can be saved in such a manner. So, but ultimately, proper understanding and designing of the BMS will plays a major role in giving the better fast charging performance.
Mamageshwari, sir.
Yes, ma'am.
Sir, in the case of battery management system, which control will be preferable for maintaining the temperature? Actually, it falls under thermal management. Is there any specific control technique for maintaining the battery temperature, sir? Or
see, the control technique in the sense, I understand that you are asking in the terms of controller perspective, whether it's a PID controller or a fuzzy or a AA based like that.
yes,
that again depends upon rather than the control technique, the actuating mechanism what we are using, whether it is a air based cooling or a water cooled or a liquid cooled or a hybrid cooling mechanism or a refrigerant cooling mechanism, that make more sense, or that plays the major role.
or that we need to design a controller.
Yes, of course. Yes, of course, we need to design a controller. But generally speaking, this PED is most widely used in case of the any control system with respect to the vehicle application, due to its less complexity as compared towards the other. But nowadays, the other non-linear control techniques also has been used. So here the challenge in battery management system is that most of the informations are not directly measured, or not directly measured. It is calculated or estimated. So how effectively you are estimating the battery temperature, cell temperature, or a module temperature, so that makes more sense rather than the control technique.
Okay, thank you, sir. Sir, in what way AI technique will be helpful in BMS management?
AI has a very wide application in the BMS, starting from its health analytics, health prediction, battery failure rate prediction, similarly driver suggestion model, Likewise, similarly, depending upon the battery conditions, the driver can get the suitable information about the driving characteristics, whether he is driving in a good way or a bad way. Likewise, the data analytics, because lot of data are generated from the battery management system, those data can be effectively used to estimate the battery health and remaining useful life. Like those aspects we can able to contribute with the help of the AI-based systems.
Sir, is there any specific machine learning algorithm which can be used widely for battery management systems?
Actually, in our lab, we will be using the SVM technique or different. Almost all algorithms we have tried, but there is not much variations. But as I told, how much data you are extracting, so that makes more sense rather than the what I call proper algorithm.
Okay, sir. Thank you, sir.
Thank you, ma'am.
Sir, I have one more question.
Yes.
In your lab and in your research projects, for the final deployment of the code, what kind of a controller you use, sir? For example, TI controllers or STM controllers? Or what kind of controllers you use?
Yeah, as of now, we had tried with PID, adaptive PID, SMC. We had tried for motor control, and to a certain extent, fuzzy also we have tried for the motor control operations.
Okay. Sir, one more question. So for modeling the plant, generally you use the Simulink block set or?
Yes, of course. You can go through my Google Scholar and recent papers, maybe last couple of year papers. There are some papers you can able to find how we have developed the model and how we have done the hardware and web simulation.
So there is two questions in the chat box. One, Mr. Jevelu, yes.
One second, sir. I will check it.
I will read it, sir. Dear Professor, please explain the wireless charging if possible.
Wireless charging, I'm not that much comfortable in that. Maybe I can skip that question. And cost and various materials used in battery. So as I told, the battery materials on slide, around 50% of the materials used in the battery, lithium-ion battery, is the graphite. And if it is lithium, it is around 3 to 4% only. And more importantly, the varieties of lithium oxide combinations will be varied. Either it is a lithium cobalt, lithium titanate, or lithium phosphorus. Likewise, different material combinations will be used. So most widely used is the lithium ferrophosphate type of battery.
Sir, good evening, sir. This is Balashnasan here.
Good evening,
so, on behalf of our organizing team, I will extend my gratitude to all of the participants who have attended today for the session of electric vehicle, drive, train, and BMS. I first and foremost, I would like to thank Dr. B. Ashok, who graciously accepted our invitation, and they have presented a very good lecture on the same topic. This session has covered the topics which is like the person who has very limited knowledge on the electric vehicle transmission system as well as BMS, and it also covered the person who had expertise or who is in need of expertise on the same topic. This session was a very informative session, and it was in a very short time also. Everything was delivered in a very short time. I thank again Dr. B. Ashok for this time, and I would like to thank all the participants who have attended the session till now. And thank you all, sir. Thank you.